Hello everyone, I welcome back you all to my YouTube channel. My name is Rajat and in today's video we are going to cover stress testing. Basically, stress testing we have already covered a video, but in today's video I am going to cover the three conditions which come with the stress testing. And we are going to implement all this using the PySpark. So we would be using Python, we would be using Spark, we would be using machine learning and banking as an example. And the focus will be how to validate model using stress testing three scenarios, which are baseline, adverse and extreme. So without wasting your time, let's move forward and let's start discussing. So guys, as you can see on your screen, basically the target is to achieve and understand the stress testing completely. Okay. So before moving to the scenario and the code, let me rephrase it because in the previous video, I already told what is stress testing. In banking, you have some models, right? So in banking, number one is your products like your credit card, your debit card, and then you have loans, mortgages, house loans, student loan, all of them are your products. And on the basis of that, to secure the principal amount, if the people are defaulting, let's say somebody is not paying you the loan, so that is a loss, right? So to cover that loss, bank always make sure that they keep in advance a mechanism where they don't need to take the help from anybody. Okay, they don't need to take help. So guys, let's start today's discussion. Okay, so as I mentioned, the topic for today is going to be stress testing. What is a stress testing? When in the credit risk models which bank are running, there are chances that people will default. So to take care of the default, bank predict them that these are the people who can default, basically the customers which bank have. Now to predict, there is a code which bank write that is known as a model. Okay, and the team who is doing all this, that is the model development team. Now there are other teams after the model developed, so there are a team who is basically working on the validation of the model, whether the development is correct or not. So that is known as model validation team. Now this stress test is one of the major model validation techniques which they do perform. What does that mean? So they put that code in a condition that if the stress is on the assets, there can be multiple type of stress. Let's say a person level issue. Let's say the person lost the job, like the customer lost the job, so they will not be able to pay the EMI. This is one scenario. Then there are some adverse scenario. Let's say, for example, the economy growth is low for that particular country because of so many reasons, like share market has been crossed, right? That could be one scenario. Then extreme cases. Okay, if you see here, so the extreme case we'll talk about, let's say COVID. When corona came into the picture, okay, nobody ever thought of it, okay, but suddenly many people were houseless, they were not able to pay the EMI. So to check such kind of conditions, this is the test which banks usually perform, is known as stress test. And then that stress test have three scenario, which is baseline, adverse and extreme. I just gave you one example for that. Okay, now let's move forward and let's start discussing here. So first I have actually given some definitions that what actually we would be achieving. Then in the second cell, I do have this code which I'll be discussing later with you guys. So let's start with the definition first because that's important to understand. Now, what is mortgage? Because I would be running this code on the mortgage data. Now, define mortgage data, import and create a mortgage. And one more thing, guys. Before I start this, so you will get whole sheet, you will get this Python code, you will get the definition also there on my GitHub repository, so you can download it from there. I will put the link in the description box, so don't worry on that, just focus on the concept. Now what is mortgage? Import and create a data file that holds sample mortgage to that. This is a real life scenario, that's why I'm mentioning all this. Include loan balance, how much the balance of the loan is left, then the interest rate, loan to value ratio which is calculated by bank, then credit score of the person and the property value. And then we have some other columns as well, like credit score. What is the credit score of the customer? Like history wise, what was the credibility of the customer? So that is very important. And then property value at present. Then we have the definition. So all this value you will be able to download and see at your own level. Okay, now my point is the core objective of this code. Okay, I'll not go much in the theory because that is something you can read and you can understand very easily. If you'll have any questions, so please do comment. Okay, I'll reply to that. Now let's move on to the code part of this, because that is the bread and butter, whole and soul. Now The first thing is that from PySpark.sql.types import structure type, structure field, string type, double type. And in this particular code, we are going to create 3 scenario for the stress testing so that you can understand 3 of them. Okay. So in the first step itself, I am defining the schema for scenario results. Now, what are the scenario? I already told you, right? So this is the whole syntax. So you're defining a variable and then the structure type. So the field will be scenario and total loss. So in the output, you will see that there will be one scenario, whether that is baseline, adverse or extreme, and then the total loss in that particular scenario, which will tell the bank that if you follow this scenario, what will be your total loss. So that's very easy. Okay. Now, let's move forward. So you can see that initialize empty dataset with the schema. So I'm just initializing an empty dataset. In that particular dataset, I'm going to put the data. So if you have an input file, so you can create the data step like on the very first go. Okay. What I am doing here, I am creating a small data so that you guys can understand, and I can give you the code also, because if I import a file, that will be really problematic for you, like changing the path at your own system. So that should be not the case. Now, the first thing I do the initialization of all the important library in PySpark. Okay. So in PySpark, I'm using the SQL library, which is the most important one other than the machine learning itself. So in the SQL, if you see Spark session, then I'm calling the call, when, lit and UDF, and then data types I'm calling for the column value definition, which I'm going to define, and then I'm just initializing the Spark session. I'm building the Spark session here, and you can do it with any name. So whatever the name of your project, you can give the simple name to the Spark session. Now here we are creating the data. Okay, let's move to this step where I'm creating the data. So you can see I'm creating the data for 3 ID, and the columns are loan ID, loan balance, interest rate, LTV, loan to value ratio. What is loan to value ratio? Let's say, for example, when you go to the bank to apply a loan, let's say you are buying a flat. So in that flat, you usually apply for 80-90% of loan. So that 80-90% which bank approve, okay? Bank is telling no, we can give only 73% of the loan on this particular property. That 73% is loan to value ratio. That's how bank calculate that. Now, the credit score on the basis of the credit history of the person or the company, whoever is taking the loan, then property value. So we have 3 people and the loan ID is 123. So now in this particular line mortgage DF, I'm just creating this data frame calling spark.create data frame and then the data and the column. So data is ready. Now this is the catch. This is the bread and butter of this whole and soul and the code. So the thing is, I am creating the baseline scenario, then I'm creating the adverse and the extreme. So all of them have a different kind of multiplier. So for the baseline, which is the bottom up, okay, so that is 0%, like 0 multiplier, because there is this is considered as a standard condition, like generic condition. Then you have the unemployment increase. So that is a adverse scenario. Then there is a value of unemployment raise, let's say 20%. So in the economy there is a downturn, that's why the this unemployment condition is rising up. So that's why we are giving it 20. So to the extreme, you can understand as different condition. Let's say like tsunami is coming, or it happened in some country, or let's say some earthquake came, or let's say the COVID happened, corona happened. So all of them are part of extreme. Adverse is something like GDP fall or some share market crash, which gradually actually picks up very faster compared to the extreme scenario. So I'm giving the multiplier for all of them, and the highest multiplier you can see, right? Highest multiplier is this one, which is the extreme scenario, and the decline also is highest here compared to adverse. I hope this makes sense as of now. Now what I'm doing, I'm calculating the PD calculations here. So I'll calculate the probability of default, that what are the chances that the customer will default. So everything we are doing in PySpark only. So the number one thing is I'm pulling a UDF. Why I am doing it? Declare a user defined function to calculate base probability of default. So this is a user defined function and I can call it anywhere. So what is the function now? Def and the name of the function. Then this is the parameter you're passing inside. It will return the value. So this is the formula which your company will give you. Okay. So I am calculating it on the basis of the US markets. Usually they do this kind of formula. In all the bank you will see the formula, and there are multiplier given to you. Okay. So you can see all these multipliers, this 0.2, you can see it's coming from the up values which I just showed you. Okay, so there is a probability of default which is getting calculated, then initialize result data frame with explicit schema. So you will have the scenario and total loss. So because that calculation will go for all the three scenario. Now I'm putting that in the data frame which I already created. So iterate through the schema. So I'll do the parameter calculation, everything on the basis of the schema, like what type of schema it is. And what does that mean? Totally depends on the scenario. Let me come back to that. Apply scenario parameter. So for all the parameter, the scenario will be totally different. If you see mortgage stress, so that is the dataset name because this portfolio itself is the mortgage portfolio. So what I'm doing, I'm using with column, which is a function, then stress property value and 1 minus palm property value, which is the stress testing formula. If you see my previous video, come in the same playlist, you will understand this formula completely because today is a fully hands-on session. I'll not go in detail, otherwise it will be so much lengthy. Now, if you see stressed LTV, what is that? Loan to value, stressed one. Okay, then that is the calculation happening here for that. Then you see the LGD value calculation is happening here, and then the calculated based PD on the basis of the credit score that is coming here. Then stressed PD and expected loss. So all these values you can see, and you can read the comment when you'll execute this code, so you'll understand much more, and read it very silently, wisely and slowly, so you understand the meaning of each and every word, because in credit risk every word have a proper meaning, otherwise you will not get the banking knowledge. Now let's calculate the total loss for the scenario. So here we are doing that using the indexing. Total loss will be the sum of everything. Now append result to result data frame. That's all we are doing here. And in the last, when I'll run this code, so you will see the scenario and the total loss for each scenario. So that's what will come in the last. Now let me select this code and run this. So this will run on this cluster which is named Rajat. So you can create your own cluster with your own name or whatever you want to do. So I just ran this code in PySpark. Okay, it's running at the moment. So let's wait for a couple of seconds. So you'll see the output down. So it's running. It's creating the output here. See guys, credit risk is a super job rich portfolio. Like in credit risk, if you understand all this, you will get a job in banking sector. That is also in modeling teams, that I can assure you. So just understand what I'm trying to give you here. Okay, so the code executed perfectly, and you can see that there are three scenarios. This is the actual part which I wanted to show you. Now as a banker, that's all you want to know. Like in the stressed situation, in the baseline, this is the maximum loss we can get. So that is close to 4,36,000, and it's in USD, let's say. So adverse scenario, 4,79,000 increased, right? Obviously it's a much complex scenario compared to baseline. So that's why the output is more. And if you see in the extreme scenario, the loss is the highest. Let's say when COVID came, so people were not able to pay the amount. So that's what the extreme scenario is known as. So I hope now you guys are much more familiar with the stress testing on a practical level, because the previous video was more centric towards the functional knowledge and practical knowledge. Today's video was fully practical knowledge. On that note, if you like the video, please hit the like button and please subscribe to my channel if you're coming for the very first time. We'll see you in the next video with some amazing content. Till then, happy learning and keep supporting to me. Thank you so much, guys.